Hi, so this is Jono from Seneca, and this is going to be an ideal addition to your revision repertoire because I'm going to be going over the ideal gas equation for your chemistry A level exam. I'll run through some calculations, I'll go over the calculation components and the formula components to get you fighting fit for your chemistry exam. Let's dive in. So, most gases obey a simple law known as the ideal gas equation. This describes the relationship between the pressure, volume, and temperature of a gas. Now, the ideal gas equation is pressure times volume equals number of moles times gas constant times temperature. And often we write this as PV equals nRT. Now, this equation can be used to calculate any variable in the equation as long as you have three other variables. So P, V, N, and T are the variables, but R is always constant, okay? R is always 8.314, okay? 8.314. Okay, the best way to get up to speed with the ideal gas equation is to do a cute little run through. So what are we waiting for? Let's say we have a straight chain alkane in a sealed container at 298 K. That's the temperature. So temperature is always in K, and 10 to the 5 pascals pressure. And this produces 0.1 m cubed of carbon dioxide and 0.125 m cubed of water. Now, what's the empirical formula of the alkane? Okay, so that question strikes fear into your heart. Don't worry about it. That's why I'm here. I'm going to talk through how we would solve this equation. So we would rearrange the ideal gas equation to get the number of moles. So if we remember, the equation is PV equals nRT. So to get the number of moles, or N, as the key subject of the equation, we can rearrange it to get N equals PV divided by nRT. Now, all we have to do is sub in all of the different variables. So P, our pressure, that was 10 to the 5. And we times that by 0.1 because that was our volume of carbon dioxide. Remember, carbon dioxide is a gas, so that's how we get our volume. And then we divide that by RT. Our R was a constant, so that's always 8.314. And then we times that by our temperature, which was 298 K, and that gives us 4 mole. Now, that was for carbon dioxide, but if you remember in the question, we also produce 0.125 M3 of water. Now, water, you might think it's a liquid, but remember we get water vapor, so it's also a gas, so we can use the ideal gas equation. Great. So, same process as before, we make the number of moles the subject, and our calculation is going to be 10 to the 5, that's our pressure, times by 0.125, that was how much water we made, so that was our volume of water, and then we divide that by the same thing we did before, 8.314, our constant, times by 298, the temperature, and that gives us 5 mole. So we can then calculate the number of moles of carbon and hydrogen atoms. We had 4 moles of carbon and 10 moles of hydrogen. So our empirical formula is going to be C2H5. Remember, we're told this was an alkane at the start of the question, so we know there's no oxygen in the compound that we burnt. So all we can have is carbon and hydrogen. And we had 4 moles of carbon in carbon dioxide, and we had 10 moles of hydrogen in water, because remember water is H2O, so the 5 moles of water gives us 10 moles of hydrogen. Okay, so shout it out to me. What is the ideal gas equation? It's PV equals nRT, okay? And what is the constant? The constant is R, and that is 8.314. Okay, I hope that was a useful run through of the ideal gas equation. I would listen to it again and maybe write up the calculations to get up to speed on it. Important equation that gets used a lot later in the course as well, so it's a good thing to get up to speed with and be confident with. Thank you for joining, and I'll catch you on the next episode.